Hi friends, here in this video I would be explaining a problem on simple machines, so let's get started. Now here is the question in front of us. Whatever is given, I'll write that in the form of data. It is given the diameter of a wheel in a differential wheel and axle is 36 centimeter. So the type of machine given here is differential wheel and axle, that we have to mention in the data. The diameter of the wheel given is, this wheel is the effort wheel and whose diameter is 36 centimeter denoted by capital D. The axles are 9 centimeter and 6 centimeter in diameter. So in a differential axle and wheel there are two axles. One is the bigger axle, other is the smaller axle. Bigger axle diameter is given by D1, smaller axle by D2, and these axles are connecting the load. Then if the efficiency of the machine is 80%, in the form of number it would be 0.8, that is dividing by 100. Find the load lifted by an effort of 100 Newton. So we have to find out how much is the load lifted by applying an effort of 100 Newton. So this is the question in front of us. Now whenever the question is specific, like it belongs to a type of machine, that is differential wheel and axle, so we have to use the velocity ratio formula for this machine. And how the velocity ratio formula has been developed for a differential axle and wheel, for that you all can refer my previous video on differential wheel and axle, whose link is being provided in the description. So you all can refer the formula for velocity ratio of differential wheel and axle. I am starting with that into the solution part. Since for differential axle and wheel, the velocity ratio formula is given by 2 times of capital D upon D1 minus D2. Now here all the values are known to us, so we can put the values. Capital D is 36, D1 is 9, D2 is 6. So from this the velocity ratio comes out to be 24. Now the question is, we have to find the amount of load which has been lifted. For that I use the efficiency formula. And this is the general formula which is used for all kinds of simple machines, that the efficiency is given by, it is mechanical advantage upon velocity ratio. Mechanical advantage is given by W upon P, that is load upon effort, into VR. So therefore efficiency is known to us, that is 0.8. The amount of load lifted is the question. Effort P is given as 100 and velocity ratio is 24. So from this we are going to get the value of load, and it comes out to be 1920 Newton. So that's the answer, or we can say it is 1.92 kilonewton. So this was a simple problem regarding the differential axle and wheel, in which we had calculated the amount of load lifted which has been asked in the question. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.